So in this video, let's take a look at one of the homework exercises for Chapter 11 that we worked on the blackboard yesterday. I'm going to do it here in this video using a shorter method than we used on the board that works because we can prove two properties about complex numbers first. So the question we are asking in this video is is the complex conjugate operator linear, or if we take the complex conjugate of C1F1 plus C2F2, is that C1F1 asterisk C1F1 complex conjugate plus C2F2 asterisk, where in both cases asterisk is complex conjugate. So to make it easier to do this problem, let's prove two little theorems about involving arithmetic for complex numbers. So let's let the complex number z be a plus bi, and the complex number w be c plus di. And we want to look at what happens when we add these two complex numbers together and then take their conjugate, and we're trying to see if that's the same as z conjugate plus w conjugate. So let's first look at what this means in terms of A, B, C, and D. So we've replaced Z with A plus BI and W with C plus DI. We are adding them together, and then we are taking the complex conjugate. So to make it easier to take the complex conjugate, we have grouped this expression differently. We put A plus C first. That's the part of this number here that doesn't involve I, and then we've taken the two parts of this number here, Z plus W, that does involve I, and factored the I out. That's going to make it easier to take the complex conjugate of the sum. So let's first note that when we take the complex conjugate of any complex number A plus BI, we get A minus BI. So let's apply that to taking the complex conjugate of this number here. So when we do that, we reverse the sign of the complex part to give us this expression right here. And so the question is that the same as the complex conjugate of Z plus the complex conjugate of W added together? So let's investigate that on the next blackboard. So Z is A plus BI, and Z conjugate is A minus BI. W is C plus DI. W conjugate is C minus DI. So we're going to add these two conjugates together. And notice that when we group the real part, we get A plus C, and when we group the imaginary part, we get minus I times B plus D. And if we look back to what we had on the previous blackboard, we see that that's the same as what we had for Z plus W added first, and then complex conjugate. Right, the same as what we had right here. So we can conclude this, that when we add two complex numbers together, Z plus W, and take the conjugate, that's the same as taking the conjugate of the first and then adding that to the conjugate of the second. Now let's see if a similar rule applies when we multiply two complex numbers together. So is it true that if we multiply Z times W and take the complex conjugate, that's the same as taking the complex conjugate of Z and multiplying that by the complex conjugate of W? So we set it up by writing Z as A plus BI, and W as C plus DI. We're going to take that product and then take the complex conjugate of that. And then we're going to see if that's the same as what we get by taking the complex conjugate of Z and multiplying that by the complex conjugate of W. So let's start on the left-hand side and rewrite this expression on the left-hand side. So we're going to FOIL this expression inside the brackets on the left-hand side, And we're first going to do that by taking the outer and adding that to the last. Excuse me, that's the, remember FOIL is FOIL, first, outer, inner, last. What we're going to do first is do the first plus the last, because that's the part that does not involve a complex number, right? So we're going to take this times this plus this times this. And when we do that, we get AC plus BI times DI. So BI times DI is BD times I squared, and so that is AC minus BD. That's the part that does not involve I. So right here we've got the outer plus the inner collected together, right? The inner is BC times I, and the outer is AD times I, and when we factor out the I, that becomes I times BC plus AD. And then, remember, we have to take the complex conjugate of that, which changes the sign of this part to negative. So here's what we get on the left side. We get this expression here. So now let's start working on the right-hand side. So we are going to do the FOIL again, and again we're going to do first times last, right? The first is A times C, and the last is minus BI times minus DI. And when we collect that together, this part right here is B times D. The two negative signs become positive, but the I times I becomes this minus sign right here. So this is the real part of our complex number on the right side. Now, if we do the outer plus the inner and group them by factoring out the I, the outer part is AD or minus AD times I, and the inner part is minus BC times I. We factor out the I and put a negative sign out front, and we get this expression right here, which is the same as this expression right here. Or the conclusion is, the generalization is, Z times W asterisk is the same as Z asterisk times W asterisk, where asterisk means complex conjugate. So using this result and the similar one involving the sum of two complex numbers, we can pretty easily show whether the complex conjugate operator is linear. So we want to show whether C1 F1 plus C2 F2 conjugate is linear, meaning it should equal C1 F1 conjugate plus C2 F2 conjugate. So if we rewrite the left-hand side using the first property that we developed, the complex conjugate of the sum is the sum of the complex conjugates. And now we're going to use the second property that we developed to rewrite these two expressions here. The complex conjugate of the product is the product of the complex conjugates. So we've written the product of the complex conjugates, and it's clear that this is not equal to the right-hand side, because that would require that C1 asterisk equals C1, which it would not unless C1 is not a complex number, or in other words, only if C1 is a real number, and it also would require that C2 asterisk equals C2. Neither of these are true in general, and so the conclusion is that the complex conjugate operator is not linear. So here is our conclusion: the complex conjugate operator is not linear because in general C1 asterisk would not equal C1 and C2 asterisk would not equal, or C2 asterisk would not equal C2 only if those two constants are real, which we cannot necessarily assume. So that concludes this video on this homework exercise.